a is an integer such that a by 23 factorial equals 1 plus 1 by 2 plus 1 by 3 plus so on till 1 by 23. The remainder when a is divided by 13 is. Let's get started. Before getting into the solution, I would like to explain what congruence is. When we write a congruent to b mod m, it means m divides a minus b. Now from the definition, it's very clear that a congruent to b mod m, b congruent to a mod m, and a minus b congruent to 0 mod m are same. Here a, b and m are all integers and not natural numbers. If we know a congruent to b mod m, then we can surely say a power k congruent to b power k mod m, but not the vice versa. And this is because a power k minus b power k is always divisible by a minus b. And if you know a congruent to b mod m and c congruent to d mod m, then you can say a into c congruent to b into d mod m. Similarly, if you know a congruent to k mod m and b congruent to k mod m, then you can say a congruent to b mod m. After learning all these properties, let's understand about the remainders. When you divide 29 by 8, you can represent it as 29 equals 8 into 3 plus 5, or 8 into 2 plus 13, or 8 into 1 plus 21, or even 8 into 0 plus 29. You can also write it a bit differently. You can write it as 8 into 4 minus 3, or 8 into 5 minus 11. From here, I would like you to notice that 29, 21, 13, 5, minus 3, minus 11, all of these differ by a factor of 8. And hence, when you look at the remainder mod 8, then all of these are equivalent. This comes handy when we want to reduce large numbers. Let's look at the solution and this will be more clear to you. We have a equals 23 factorial by 1 plus 23 factorial by 2 plus so on till 23 factorial by 23. Here, except for the term 23 factorial by 13, every other term is a multiple of 13, as 23 factorial already contains a 13 in it. Now, the remainder when 23 factorial by 13 is divided by 13 will be the remainder when the whole expression is divided by 13. From here, we get 23 factorial by 13 equals 23 into 22 into 21 into so on into 14 into 12 into 11 into so on till 1. Now, dividing each term by 13 and using the remainder if it is less than or equal to 6, and otherwise subtracting 13 from it and then writing the new remainder as how we discussed before, we get minus 3 into minus 4 into minus 5 into minus 6, 6 into 5 into 4 into 3, into 2 into 1, into minus 1 into minus 2 into so on till minus 6, into 6 into 5 into 4 into 3 into 2 into 1. Here, we could multiply these remainders in order to get the final remainder, because we know that if a congruent to b mod m and c congruent to d mod m, then a into c is congruent to b into d mod m. Simplifying this, we get 3 into 4 into 5 into 6 power 4 into 8. Now 3 into 4 is 12 and 5 into 6 is 30. 12 is minus 1 mod 13 and 30 is 4 mod 13. Substituting them back, we get 16 square into 8. 16 is 3 mod 13. Now we have 3 square into 8 in hand, that is 72. 72 upon division by 13 leaves a remainder of 7. This means 23 factorial by 13 is congruent to 7 mod 13, and hence a leaves a remainder of 7 upon division by 13. Thank you.